Hello, welcome to Anybody Can Learn. Today we will solve a problem based on the concept of subgradient. So let's first understand what does the subgradient means. Recall what is a function. A function is a mathematical rule that takes an input and produces an output. We usually write the function as y is equal to f of x, where x is the input. It is also called as independent variable. F is the rule or mapping, and y is the output, also called as a dependent variable. For example, y is equal to x plus 3. Suppose x is 2, then y is 2 plus 3 is equal to 5. So the function maps the input 2 to the output 5. In a graph, it shows how the output changes as the input changes. For example, if the function is y is equal to x square, it is a parabola. So these indicate this is the output, how output changes as the input changes. What is a slope? Imagine you are climbing a hill. There is a three possibilities. First, flat road, that is no rise, so the slope is 0. Uphill road, then the road rises, so the slope is positive. Or there may be a downhill road, that means road falls, so slope is negative. Mathematically, the slope tells us how fast the output changes when the input changes. And the formula for slope is m is equal to y2 minus y1 divided by x2 minus x1, where x1 and y1 are the first point and x2 and y2 is the second point, and m is the slope. What is a tangent? Imagine a ruler touching to a circle at a one point. Then that ruler represents a tangent. For a curve, a tangent line just touches at a one point, and the slope of the tangent is called as a derivative. The slope of this tangent is called as a derivative. Derivative simply measures the slope of the tangent line. Derivative tells how fast the function changes at specific point, and it is written as derivative of the y with respect to x, where d is the small change, that is small change in the y, and dx is a small change in x. If y is a x square, then dy of dx is 2x. Suppose x is 3, then derivative of the y with respect to x is 2 multiplied by 3 is equal to 6. So the slope at x is equal to 3 is 6. What is a gradient? A gradient tells us how fast the function changes. In one variable, the gradient and derivative are the same, but in multiple variables, the gradient is a vector containing all partial derivatives. Let us see the example for one variable. For y is equal to x square, the gradient is simply 2x, because here we are using only one variable. In multiple variables, for example, f of xy is equal to x square plus y square, then del f is equal to partial derivative of f with respect to x, comma partial derivative of f with respect to y. So this symbol is called as a del, that is a gradient operator, and this is called as a partial derivative symbol. So for this example of x square plus y square, df partial derivative of f with respect to x is 2x, and partial derivative of y f with respect to y is a 2y. So del f is 2x comma 2y. Now try to understand a differentiable function. A function is differentiable at a point if it has one unique derivative at there. Think of drawing a graph without lifting your pencil. There must be no sharp curves or corner. At that point, there is a one tangent line and one slope. For example, y is equal to x square. This curve is a smooth everywhere. Every point has one unique slope, so it is differentiable everywhere. So remember that smooth curve is differentiable. Now let us understand left and right hand derivatives. When checking a joining point, we compute the left hand derivatives, that is approaching the point from the left side, and right hand derivatives RHD, that is approaching the point from the right. If left hand derivatives LHD is equal to right hand derivatives RHD, then we can say that function is differentiable. Or if the LHD left hand derivatives is not equal to RHD, then we can say that function is not differentiable. A function is non-differentiable when there is a no unique tangent line at a point. Common reasons are the sharp curve, vertical lines, discontinuity, etc. For example, y is equal to absolute value of x or y is equal to modulus of x. At x is equal to 0, the left slope is -1. Also, at x is equal to 0, the right slope is plus 1. That means the LHD left hand derivatives and right hand derivatives are different. So LHD is not equal to RHD at this sharp corner. Since they are different, the function is called as non-differentiable at x is equal to 0. So remember that in a non-differentiable function, there is a no unique tangent line. What is a convex function? Take any 2 points on a graph and join them with a straight line. If the function is convex, then the entire line segment lies on or above the graph. Now let us consider a bowel that opens upward. If we stretch a string between any 2 points on the rim of the bowel, the string stays above the bowel. So we can say that it is a convex. The string always stays above the line. The example of the convex function is x square is a convex, and modulus of x is also convex. What is a subgradient? The derivative works only when the function is differentiable. But many optimization problem uses a function with corners like f of x is equal to modulus of x. At x is equal to 0, there is a no derivatives. Instead stopping, optimization uses subgradient. A subgradient is a generalized slope that extends the derivative to certain non-differentiable convex function. If a function is differentiable, then it has only one subgradient, and that is equal to derivative. If a function is a convex corner, then it has many subgradient. For example, f of x is equal to modulus of x, then at x is equal to 0, every value between -1 and 1 is a valid subgradient. Just now we saw that f of x is equal to modulus x at x is equal to 0 is non-differentiable function because it has many tangent. Therefore, it is a non-differentiable and its left hand derivatives is not equal to right hand derivatives. As it is a non-differentiable function, it has many subgradients. Now let us compare the gradient with subgradient. A gradient defined only for differentiable points, whereas subgradient can also be defined at a certain non-differentiable convex point. Gradients is always a unique and subgradient may be one or many. Gradient give exact slope of the tangent, where subgradient gives a valid supporting slope for optimization. Gradient use in ordinary calculus, whereas subgradient use in a convex optimization, SVM, lasso, etc. Before solving a problem, let's revise some important concept. A function is a rule that maps an input to an output. Slope is a rate of change between the 2 points. Tangent means a line touching a curve at one point, and derivative means instantaneous rate of change, that is slope at a point. Gradient means generalization of derivatives. It is a scalar in one variable and a vector in multiple variables. A differentiable function is a function with one unique derivative at the point. Left hand derivatives is the slope when approaching from the left hand side, and right hand derivatives is a slope when approaching from right hand side. Non-differentiable function is a function with no unique tangent at the point. A convex function is a function whose graph always lies below the line segment joining any 2 points on it. A subgradient is a generalization of the derivative for a convex function that may not be differentiable. Now let us solve a question. Consider the following piecewise function. F of x is x square, where x is less than or equal to 1. F of x is 3x minus 2 when x is greater than or equal to 1 but less than or equal to 3. F of x is 5x minus 8 when x is greater than or equal to 3. So there are 4 points B, minus 1, 1, minus 1, 1. B2 is 1 comma 1. So this is B2 point. B3 is 2 comma 4. B3 is 2 comma 4 and B4 is 3 comma 7. This is B4. So the question is, how many subgradients are possible at points B1, B2, B3 and B4? Piecewise function means a function uses different equation for a different condition. So fx uses the equation x square when x is less than or equal to 1. At the same time, fx uses a function 3x minus 1, equation 3x minus 2 when x is greater than or equal to 1 but less than or equal to 3, and fx uses equation 5x minus 8 when x is greater than or equal to 3. Now let us recall the basic rules. D of x square with respect to derivative of x square with respect to x is 2x, and derivative for a straight line, that is derivative of ax plus b with respect to x is a. So for example, derivative of 3x minus 2 is 3 and derivative of 5x minus 8 with respect to x is 5. The differentiability test is comparing the left hand derivative and the right hand derivatives. If LHD, left hand derivative, is exactly equal to the right hand derivative, then we can say that function is differentiable and it has one subgradient. But if LHD is not equal to RHD, that is left hand derivative is not equal to right hand derivative, then we can say that function is non-differentiable and it has many subgradients. So let us calculate the derivative for every part. So f of x is equal to x square, then its derivative is 2x. For second part, that is f of x is equal to 3x minus 2, the derivative is 3. And for third part, where f of x is equal to 5x minus 8, then derivative of third part is 5. So this is how the graph look like. Point B1 and B3 that completely lies inside their section, and but point B2 and B4 are at the junction where the function meet. So let us analyze the point B1, that is minus 1 and 1. So point lies completely inside the x square part. So this is a smooth curve, so, and its derivative is 2x. So at x is equal to minus 1, we will substitute it inside this derivative function. So 2 minus 1 is minus 2. So there is only one slope, that is minus 2. So exactly one gradient. The point has exactly one gradient. Therefore B1 has the one subgradient. Now analyze the point B2, 1 comma 1. For the B2, we will use the function, it lies at a two junction point. Three x minus 2 as well as x square. So B2 lies at junction point 3x minus 2 that is a straight line, and x square, this is for a parabola. Just now we say that the B1 point lies at the entirely in one section because x is less than 1. So here minus 1 is less than plus 1. So it lies at this point, parabola point. Point B3, B3 always lies in this one junction, green line, because x is 2 here. So 2 is lies between plus 1 and plus 3. So this will follow 3x minus 2 equation. Now consider the B4 point where x is 3. So 3 is greater than or equal to 3. Therefore B4 will lies at the junction between 3x minus 2, this straight line, and the junction between 5x minus 8. 5x minus 8. So it lies at the 2 point, at the junction between the two equation. Now let's analyze the point B2, which is 1 comma 1. At the point x is equal to 1, the parabola and a straight line meet here. So let's calculate it left hand derivatives. Left hand derivatives is using a 2x. So 2 into 1 is 1. So substitute the value of the x, that is 1, in these left hand derivatives. So it is a 2. Now substitute the 1 at, and its right hand derivatives is 3. So left hand derivatives 2 is not equal to right hand derivatives 3. Therefore it is not differentiable. Therefore B2 has many subgradients. Now analyze the point B3. B3 is a 2 comma 4 point. 2 comma 4 point. So it lies completely inside this green line, that is 3x minus 2, because x is 2 is greater than 1 but less than 3. So the function will follow the equation y is equal to 3x minus 2. So its derivative we calculated it at 3. There is only one slope, therefore function is differentiable here. So B3 has one subgradient. Now consider the point B4, 3, 7. At point x is equal to 3, it will follow the 2 function, because the y is 3x minus 2, because x is 3 and y is equal to 5x minus 8. So x is greater than or equal to 3. So at B4 the left function meets the right function. So left hand derivatives, that is y is equal to 3x minus 2 is 3, and right hand derivatives 5x minus 8 is 5. Here the left hand derivative is not equal to right hand derivative because 3 is not equal to 5. Therefore function is not differentiable at B4. Therefore B4 has many subgradient. So let us summarize the result. In B1 we have only one derivatives, therefore it is differentiable, therefore it has one subgradient. At B2 the left hand derivative is 2 and right hand derivative is 3, which is not equal. So it is non differentiable at B2, therefore it has many subgradient. B3 has one derivative, so it is differentiable, so it has one subgradient. B4 has left derivative 3 and right derivative 5, so it is a non-differentiable, therefore it has many subgradient. So our final answer is option B. B1 is one subgradient, B2 with many subgradient, B3 is one subgradient, and B4 with many subgradient. Thank you.